Welcome to the video on graphing exponential and logarithmic functions or equations. We're going to talk about what these types of graphs look like. So we're going to start first with our exponential function, and this is the one that we call the growth graph. So some of these are going to look exactly like what you've seen before. So this one, I bet you can figure out that this is the decay graph. And we're going to talk about what the equation looks like and what numbers in the equation are going to make it growth or decay, what numbers are going to make it upside down, because in this case, this one is still a growth function, but it's also flipped upside down, or we call that reflected across the x-axis. So this one is still growth, even though it looks like it might be decay. All right. Now, if you take this exponential graph and you flip it, or inverse it, then an exponential that has been inversed is going to make a log. The inverse of a log is an exponential, and inverse of an exponential is a log. That's because they're reflections of each other. Remember that when you take a inverse, it's going to reflect it across this line that's going diagonally through the graph, which is y equals x. So again, this log graph here is an inverse of this exponential graph here. So in this video, we're just graphing the exponential functions, but in the next video, we will graph the log functions. All right, so let's talk about what the equations are going to look like. So this is your basic exponential function. Okay, remember the x is in the exponent. The negative here is going to flip this graph upside down. Okay, the 3 is going to change how steep this graph is. If the number or the base number, remember, see, this is just a coefficient in front of the actual exponent or exponential. This is the basic part of the exponential. So if the 2, which is the base, the x is the exponent, if the 2 is greater than 1, which is 2 greater than 1, yes, then it's going to be a growth function. So it's going to look like exponential growth. If that base number were between 0 and 1, which would mean it'd have to be like a fraction, 1/2, 2/3, 3/4, then it's going to be decay. Okay, so negative turns it upside down, coefficient in front changes how steep, base number, it's going to affect the shape of it as well, but we're going to look at how it's greater than 1 growth or between 0 and 1 is decay. Okay, one more thing. This negative here, that's going to help determine whether it's growth or decay. But the negative, remember, affects this number. If this negative flips this either below the fraction or above the fraction, because remember, a negative exponent flips it to the other side of the fraction. If it flips it, then you decide whether it's growth or decay, because it's always this number that determines growth or decay, but this may change it. So we are just going to say, if that's a negative, we need to decide whether it's growth or decay based on what it does to this number. All right, here we go. Graphing an exponential function. We're going to start with the basic y equals 2 to the x minus 1 plus 3. Okay. Actually, let's just talk about this shift part first. We'll do the basic one in just a minute. But here's the shift. Remember that If it's a number that's inside with the x, it's going to shift it right if it's negative, left if it's positive. Remember, if the number is on the outside, we're going to shift it up if it's positive and down if it's negative. So we've talked about where all the numbers are placed. Every graph or every function has a number in it that can tell you something about what that graph is going to look like. So here's our basic function, okay? Y equals 3 to the x, okay? So I'm going to take my numbers. Now, the first thing you're going to ask me is, so how do I know which numbers to use here to know what to plug in order to find the other side of the point? In this case, we're going to just graph it as if it were in the center of the graph with no shift or translation going on. So we're going to always use -1, 0, 1. -1, 3 to the -1 gives you 1/3, 3 to the 0, and 3 to the 1. So we've got to be able to figure these out. You have to remember that a negative exponent is going to flip that number over. In other words, if we use -1, 0, 1 all the time, it's going to make it easier for you to do this without a calculator. So let's go ahead and finish this up. This is 1/3, 1, and 3. Now I'm going to go graph. So it's -1, 1/3. So just a little bit above the graph here. 0, 1, and 1, 3. And then I'm going to graph. Now, just be careful. This is an asymptote. An asymptote is a line. I'm just trying to get it on the x-axis here. An asymptote is the line where the graph will not touch. Remember that the exponent is never going to make 0. An exponent can get as close to 0 as possible. Notice how it is going down to fractions. It'd be, 1/9, 1/27. It would get as close to the to 0 as possible, but it's never going to touch 0. So therefore, I have to make sure that I do not cross this y equals 0 line here. Okay, I have to, and that is called an asymptote. All right, so watch, we're going to do it again. When you start to shift it, that asymptote line is going to shift with the graph. Okay, so we have graphed our exponential function. Let's move on. So y equals -2 times 3 to the x. So I'm doing the same graph, except I put a -2 in front. That's going to change how steep it is, and it's going to flip that growth function upside down. So I'm going to plug in my numbers. Again, I'm using -1, 0, 1. I'm doing some of the same things so that you'll get used to it, but really use the same steps for every single problem. It's just that sometimes I want you to be able to get comfortable with some of the functions that we're doing in the video. Okay, so I did -1, okay. All right, so I did -1, 0, 1. I plugged in -1, 0, and 1 into my function, okay. I'm using the -2 because I'm going to multiply this, but notice I did, let's do this one first. So 3 to the 0. 3 to the 0 is 1, and 1 times -2 is -2. Please remember that PEMDAS says you do exponents first. So we're not going to multiply -2 times 3 first. We're going to do 3 to the 0, which is 1, and then times -2. 3 to the -1, in this case, is 1/3, and 1/3 times 2 is -2/3. Okay? 3 to the 1 is 3, and 3 times -2 is -6. So I've started to plot these points right here. This is 1, -2/3, excuse me, -1, and this is 0, -2, and this is 1, -6, and I'm checking myself. It should be upside down because of this negative right here. So let me draw this graph real quick. Make sure, check your graph. Say, okay, do the numbers in the equation match the graph that I just drew? It is still a growth graph, because if you flip this right side up, it'd be growth. All right, we're going to use 3 to the x again, but this time it's going to have a translation in it. So it's going to be 3 to the x minus 2, oh, excuse me, 3 to the x minus 1 plus 2. And in this case, I'm just going to go 3 to the x. We did this before where we took out the translation and we just did our basic function, because I want to see what the function looks like. So I don't have to use the translation when I do this. So again, -1 makes it flip over, so that's 1/3. 0 to the 1, 0, excuse me, 3 to the 0 is 1, and 3 to the 1 is 3. So I go and graph the points that I have. Okay, now this is the asymptote line, my yellow line right here. Okay, I've graphed the points, but now I need to shift them. This is going to be right 1 up 2. So let's go right 1 up 2. That red dot needs to be just a little bit higher. And then right 1 up 2, and then right 1 up 2. The asymptote just moved up 2. That's your asymptote line right there. So I can't cross 2, but I can go to 2 1/3. All right? So that is graphing an exponential function. You have to remember that we do -1, 0, 1. Go ahead and find out what your basic function looks like. And then at the end, you're going to do the translation. So graph the basic function. Okay. Using what? -1, 0, 1 for your x. And then number 2, translate or shift. Okay. All right. Let me know if you have any questions, and thank you for watching.